This video summarizes the main ideas behind the intermediate value theorem and the mean value theorem, highlights the differences between them, and shows how they might be assessed on the AP Calculus exam. Intermediate value theorem is a theorem that you did not hear about in calculus class this year, but once you hear the basic idea behind it, I hope you'll see that it's very intuitive. What it says is that if a function is continuous on a to b, so like my orange curve is continuous between x equals a and x equals b, then f of x, or the orange line, is going to take on every y value between f of a and f of b, or the y values for the endpoints. So you can see here that I highlighted the section of the graph that goes from f of a to f of b in the y direction. And you can see that the orange line actually hits every single y value in that blue section. So that's what intermediate value theorem is saying. The way intermediate value theorem, or IVT, is more typically used is described in the second little blurb on your screen. If there is a y value called k between f of a and f of b, so you see I just picked a y value that was in that blue shaded region, then there has to be an x value, and usually they just call that c, these are just kind of arbitrary, that falls between a and b that has that y value. So in other words, if you pick a y value and that y value is between the y values of the endpoints, you're guaranteed that there's an x value between a and b, where if you plugged it in, you get that y value that you started out picking. So this theorem is all about proving that a y value must exist on a given x interval. For this reason, IVT is called an existence theorem. This problem, taken from a past AP exam, shows how you might see IVT assessed on the test. The text tells us that a car is traveling along a straight track so that its velocity and acceleration are continuous functions between t equals 0 and 60, and the table gives us some values for both the velocity and the acceleration. And then it says, between 0 and 60, must there be a time when the velocity equals -5? And if you see something like, must there be a time, that's going to be a tip-off that you want to use an existence theorem. So essentially this problem is asking, is there a y value on the velocity graph that is equal to -5? And so since I'm talking about the existence of a y value, intermediate value theorem is the way to go. So the main thing I really need to look for is -5 between two y values for v of t? If you look closely at the v of t line of your table, you see that at 35 and 50, the y values are -10 and 0, and -5 is between those. Because v of t is continuous, which they told us in the problem text, that means it has to hit every y value between -10 and 0 during time 35 to 50. So the short answer is yes, there does have to be a time when the velocity equals -5. But the long answer is how you have to write it correctly. So first, you have to specify that v of t is continuous, because intermediate value theorem wouldn't apply if it wasn't continuous, because a non-continuous function could skip some y values. Then you have to explicitly state that -5 is between -10 and 0, or it's between f of 35 and f of 50. Therefore, and then you want to cite the name of the theorem, intermediate value theorem guarantees that there's going to be a t in that interval 35 to 50, so that v of t is -5. And since 35 to 50 is in 0 to 60, then there has to be a time when v of t is -5. Now, even if mean value theorem seems understandable enough, it has a lot of similarities to another theorem you saw in the first semester called mean value theorem, which is also an existence theorem, and telling them apart and when to use them can be tricky. You should recall that mean value theorem tells us that if a function is continuous and differentiable on an interval, so it doesn't break at all and it doesn't have any sharp corners, then there should be a point on the interval, and they call it c, where the derivative at c, or the slope of the tangent line, which I've shown in green, is going to be the same as the slope of the secant line between the endpoints, so the slope of the line between a and b. In other words, there has to be a point on the interval called c, where if you take the slope between the endpoints, the derivative at that point c will be the same. And you can see from the picture why that makes sense. Unlike intermediate value theorem, which is all about showing that a y value exists, mean value theorem is all about showing that a derivative value must exist. This is another part of the same problem from a past AP exam. Instead of asking if there is a time when v of t has a certain value, this problem asks if there is a time when a of t, or the acceleration, equals 0. Now, again in this problem, that phrase, "must there be a time," tells us that we have to use one of the existence theorems. But the question is, which one? Mean value or intermediate value? Again, the main difference between mean value and intermediate value is that mean value tells you that a derivative exists, and intermediate value tells you that a y value exists. So since this is asking when a of t equals 0, it sounds like this is saying, does this y value exist? So that would be an intermediate value theorem problem. However, for intermediate value theorem to work, we would have to show that the acceleration function had values above and below 0 on this interval. If it had values above and below 0, then it would have to pass through 0. But as you can see, all of the values in the a of t line are higher than 0, so IVT doesn't work. So we need a new plan. So we have to remember that we also know that acceleration is the derivative of velocity. So in this situation, we could also try to use mean value theorem to show that there is a point where v prime equals 0, and v prime is the same thing as a of t. So if we want to show that there is a time when v prime equals 0, then we need to do mean value theorem on the original v function. We're going to ignore a of t now. So the first thing we have to say is the condition for the theorem, which is that v of t is continuous and differentiable. We know it's continuous because it says that in the problem, and we know it's differentiable because we know that it has a derivative acceleration, which is also given. Then we need to try to show that a slope of a secant line between two of the points on the v of t function is going to equal 0. So this is going to require a little bit of work on our part because we're going to have to select the numbers that work. So to get a slope of 0, basically what we need is to see that the y values at 2 points on the velocity function are the same. And we do see that at 0 and 15, both velocities are negative 20. So I went ahead and found the slope of the secant line between 25 and 0, which works out to 0. Therefore, because the slope of that secant line was 0, mean value theorem guarantees there is a time between 0 and 25 where v prime of t or a of t equals 0, which is the answer that we wanted. So a good answer to an existence theorem question, one about either IVT or MVT, is going to have 3 parts of their answer. First, you're going to say that for IVT the function is continuous, or for MVT it's continuous and differentiable. Then you're going to cite either the y values that are higher and lower than the one that you're looking for in IVT, or find the slope of the secant that you're dealing with in MVT. And then at the end, you're going to need to cite the correct theorem. And to end, I just want to emphasize one more time the key words you're looking for to know that you should be using intermediate value theorem or mean value theorem. If you see a problem that says something about showing that there must be a y value, that's an automatic intermediate value theorem problem. If you see something about showing that there must be a derivative value, that's going to be a mean value theorem problem.